could take me a really long time if I have to keep like stopping because you're talking about it. Now, this little trinomial section deals specifically with what happens when you have two special cases. Obviously, that's why they say it. When you have something that either looks like this, and again, I guess it's three cases. When you have something that looks like this, x minus 3 to the 10th power, and when you have this, and I think we've talked about both of these. I guess it's the three different cases you get when you have like the same variable and the same number, and what happens each time. Let me just warn you here, we've talked about this before. A lot of people think the answer to this is x squared plus 9. It is not. Remember, if you take x plus 3 times x plus 3, you are going to get a middle term. FOIL says you get x squared. 3x and another 3x for your middle term is your 6x, and then 3 times 3 is plus 9. Really what they're, and this by the way is not factoring. Was anybody going to say, Mr. Allen, that's not got anything to do with factoring, that's multiplying?
Yeah.
Alright, but what they want to do is they want you to see when you get perfect square things here, that this could easily, that you'll be able to factor this down to x plus 3 times x plus 3. They want you to see that. They just want you to be aware of what happens when you get a perfect square there and a 6 there. Same thing with this. If you have x minus 3 times x minus 3, you're going to get x squared what? Minus 6x plus 9. Notice you still have the plus 9s and the x squareds, except this is minus in the middle. And again, you still, when you factor that down, you're going to get x minus 3 times x minus 3. But the biggest one is the last one. This is by far the most special case, because what happens when you factor, or when you multiply two binomials that are identical except one is negative, one is positive, you get no middle term, because you get x squared here, you get a minus 3x and a plus 3x, which add up to no x's in the middle, and a minus 9 there. This is the toughest one to recognize because it's not a trinomial, it's actually a binomial, but you can still factor that down into x minus 3 times x plus 3. Now if I asked you, you should be able to give me a few examples of this. Everybody should be able to give me that. What would be another example of a binomial that would factor into a trinomial? Stephanie?
X minus 25.
X squared minus 25. That would break into x plus 5 times x minus 5. Another example of one that would work like that. Somebody, anybody, Jacob Woolman.
X squared plus 4, minus 49.
Minus what?
49.
49. Again, remember, the things that have to be true for a binomial to break into two other binomials is it has to be a perfect square, and the middle must be subtraction. It must be subtraction. This won't work with x squared plus 49. You cannot factor x squared plus 49. Another example, Mary Schubert. Oh, we're working on x squared minus, did you say 100? Perfect, yes. Well, x squared minus 100 will work as well. Okay? Because that's going to be x minus 10 times x plus 10. Now, you guys are thinking kind of pretty simple here. Let's go a touch bit more complicated. What if it was this? 4x squared minus 30. Oh, wait, I don't want to do 36 because that's a different story. Let's just do 25. Still works. It's still, as long as this is a perfect square and that's a perfect square, this would break into 2x minus 5 and 2x plus 5. Okay. Same thing if you saw something that looked like this. 49x squared y squared minus 81z squared. All you have to think about is what would be the square root of this? 7xy minus 9z times 7xy plus 9z. As long as they're perfect squares, it works. As long as it's minus and or plus on those sort of things. What?
Is there any like?
Like it doesn't work out.
Yeah, you just like
It's,
find
if this would have been 80, you couldn't factor it.
They were like, no,
Yeah, that's just that's as simple as it gets right there. And again, you have to be careful. It's something like this. If it was 6x squared minus, I don't know, 16, could you factor that? You can. It may not factor into two binomials, but you can take out a what? You can take a 2 out of it and get 3x squared minus 8. Can I factor that? No. This would be all you can factor really out of that whole thing.
That makes sense.
Okay, you just have to be observant and notice what's going on there. Oh, let's do one from the book. 36x squared minus 48x plus 16. If you've got that, what is the first thing, Alexandria Lyric, you would do?
6. I got 6.
You can't take 6 out of 16. But you're close. Take out a, you can go a little higher than 2. Take out a 4 and see what happens. When you take out a 4, you're left with 9x squared minus 12 plus 4. Now you look at that, and can you factor that anymore?
Yeah.
Again, noticing that these are, again, perfect squares, will you get a negative 12 middle term if you go 3x minus 2 times, the only other way to get that would be 3x minus 2. Does that give you a minus 12 middle term?
No.
Yes, it does. Negative 6x, negative 6x, I'm sorry, this should have been an x, my bad. Sorry, I sorry. And usually the book will write it like this, it's squared. Concerns? No more than I, what might say. Oh, look at that. Sure, let's just do set number 83, practice.